So on this next one, however, I notice, oopsies, the variables don't match. So I can still use the power rule. So I'm going to power it down to y. But then I have to take the derivative of y with respect to x, because I haven't really done that. I powered down, but I didn't really take the derivative because this equation is not written with x's, it's written with y's. Another way to write this would be 2y and then y prime, because remember, these two expressions mean the same thing. So that tells the person that if I was deriving with respect to y, that then I could have done like I did in problem 1. I know it's a little weird, so just hang in there until you've done a few of them, and then it'll start to become a little easier, and then we'll add some practice to it. So this time I look, oh, I'm taking the derivative with respect to x. So this one is a match, so I can just take the derivative normally for that one. Again, powering down, so 1 times 5 is 5, decrease the power by 1. But then as on the second piece, the variable doesn't match. So although I get to use my power rule, so I'm powering down, which will be a 6y squared, I haven't really taken the derivative of y because it's not an x variable. And I can only really derive the x pieces because I'm deriving with respect to x. So the minute you change up that variable, I have to tell the reader, oh, by the way, I wasn't actually able to complete the derivative with respect to x because that variable was not a matching variable. So this is my final answer. Let's look at another one. So again on this one of the variables matches, but the other does not. In addition, I have a product rule. So I have to do first times derivative of the second, so I will power down, but it's a y, so it doesn't match. So I haven't really taken the derivative with respect to x because it's not an x. So that's first time derivative of the second, plus second times derivative of the first, but this variable was a match, so all I have to do is 2x. Here's y. I don't really have anything after it because if I said, oh, it's dx, well, that turns into a 1 anyway. Did you notice that mistake when I wrote that down up there? This should have been a 3y squared. I forgot the power. And so, so at any rate, yes, this turns into a 1, which is why I don't actually need to show it dx. I'm technically doing that, but since it equals 1, I don't show it. So I would tidy this all up by writing x squared 3y squared dy dx plus 2xy cubed, keeping my variables in alphabetical order just like normal. And if you want, you can write x squared 3y squared y prime plus 2xy cubed. Whichever notation you like better, I'm not all super picky. So I'd like to find the derivative, and I notice, hey, it's equal to a number, so this will actually be equal to something. But again, it's really difficult to get y by itself. It's kind of messy. So when that happens, I have the option of taking the derivative implicitly. So I'm going to do that. So I would start, I'm doing it with respect to x, so I'm going to start with this one. So I'll power down. So that'll now be x to the negative 1/2. Oops, I don't know why I put 2 negatives in there. And I could write dx, but I don't need to because that equals 1, so I don't bother to put it. And then plus, I'll power down on the y, so that's to the negative 1/2. And then dy dx, and then equals, if I take the derivative of a constant with respect to x, it's just 0. So I still want to get dy dx by itself, so I'll move this to the other side. And then I'll divide both sides by 1/2 y to the negative 1/2. And some things cancel out, and I have to move the negative exponents, pause the video.